In this video, we'll learn how to find area using the cross product. So let's first look at a parallelogram. We have these two parallel sides and these two parallel sides. If the length of these parallel sides are given, if this is side A and this is side B, if you know these two lengths, can you figure out the area? The answer is no, because you can have a different parallelogram with the same two sides. This is side A and this is side B. Clearly, these two have a different area. What you need is the height. So let's clean this up. If I give you side A and height, can you now find the area? Yep, there's the formula. Area equals to side A times height. Now, if you don't know the height, but you know the angle, can you still find the area? Yes, you can do that, because in this triangle, side B, height, and this theta, they're related. Height divided by side B, that's equal to sine of theta. So if you know side B and theta, you can figure out the height. And once you know the height, you can figure out the area. So let's replace height with theta and side B. This is what we get. Area equals to side A times, if you replace height as side B times sine theta, you'll get side B times sine theta. So two magnitudes and sine theta, you can see that a cross product is happening here. Now if you think of these two sides as vectors, if this is A vector and B vector, area is equal to mod of A vector times mod of B vector times the angle between them, sine of it. So sine of theta. And this is the magnitude of the cross product. Cross product is mod of A vector times mod of B vector times sine of theta times n cap. That's a unit vector that shows the direction. But if you want the magnitude, you can just look at these three values. So area is actually mod of A cross B, the cross product of these two vectors. So this is how you can use the cross product to get the area of shapes. So A and B, if these are the two vectors, the parallelogram that they form, the area of that is actually equal to mod of A cross B. And you could do the same thing for triangles. If this is the triangle and you want the area of this triangle, the triangle that A and B are forming, that's going to be equal to side A times height, that's base times height divided by 2. This thing is A cross B, mod of A cross B. So area equals to mod of A cross B divided by 2. Now area of this triangle is half of the area of the parallelogram, and we can use the cross product for both of them. So let's solve some problems. Find the area of the triangle with vertices A, B, and C, and the vertices are A1, 1, 2, B2, 3, 5, and C1, 5, 5. So pause the video, try this on your own. Okay. So to get the cross product, we need adjacent sides. So let's find any two adjacent sides. Let's find vectors along these two sides. So AB vector, that's the vector from A to B, that's going to be 2 minus 1, that's 1, I cap, 3 minus 1, that's 2j cap, 5 minus 2, that's 3k cap. So AB vector is I cap plus 2j cap plus 3k cap. Let's also find AC, that's C minus A. So that's 0 plus 5 minus 1, 4j cap plus 5 minus 2, 3k cap. So we have AB and we have AC. Now to get the area, we'll take the cross product, and because this is a triangle, we'll divide it by 2. So area equals to the cross product, magnitude of the cross product of AB and AC divided by 2. So let's find the cross product. That's equal to the determinant of I, J, K, the components of AB and the components of AC. So that's I, J, K, 1, 2, 3, 0, 4, and 3. Let's expand this. This is I cap times 6 minus 12 minus J cap times 3 minus 0 plus K cap times 4 minus 0. So this becomes 6 minus 12 is minus 6 I cap minus 3j cap plus 4k cap. Now that's the cross product. What we need is the magnitude. So let's take the magnitude of this. That's equal to square root of 6 square plus 3 square plus 4 square. That's 36 plus 9 plus 16. So 16 plus 9 is 25. 25 plus 36 is 61. So the magnitude is square root of 61. So area of this triangle is half of it. That's root 61 by 2. Let's solve one more. Find the area of the parallelogram whose adjacent sides are determined by the vectors A and B. A vector is I cap minus j cap plus 3k cap, and B vector is 2I cap minus 7j cap plus k cap. So pause the video, try this on your own. Okay. So the area is the cross product. The vectors are already given. That's mod of A cross B. So let's find A cross B. That's the determinant of I, j, k, the components of A and the components of B. That's I, j, k, 1, minus 1, 3, 2, minus 7, and 1. Let's expand this. This is I cap times minus 1 plus 21 minus j cap times 1 minus 6 plus k cap times minus 7 plus 2. So this is 20 I cap plus 5 j cap minus 5 k cap. Again, this is the cross product. What we need is its magnitude. So mod of A cross B, that's equal to square root of 20 square plus 5 square plus 5 square. That's square root of 400 plus 25 plus 25. That's square root of 450. This is twice of 225. 225 is 15 square. So this is 15 root 2. So the area of parallelogram is 15 root 2. One last problem. Find the area of the rectangle with vertices A, B, C, and D with given position vectors. Here's A, B, C, and D. Pause the video, give this a try. Okay, if you've observed the pattern, you're probably not finding the cross product. You can see that all four of them are at a height of 4 units from the xy plane. 4K, 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 and 4K. Now if you visualize this, this is the rectangle that we're looking at. It's at a height of 4 units and these are the sides. If you look at it from top, look at the x coordinates, minus 1 and 1. So the x coordinates are minus 1 and 1. So this length is 2 units. The y coordinates are half and minus half. This breadth actually is 1 units, difference between half and minus half. So length is 2 and breadth is 1. The area of this rectangle, and we don't need any cross product for this, that's equal to 2 times 1, that's 2 units.